Okay. All right. So the last time we were trying proportions and rates, right? And if I remember right, I actually tried to use a real life example to show how the proportion works, you know, what do we understand by proportions and all that. So let's try one or two more examples. And before that, if you have any questions, because I think the pre-assignment was, let me see, example 12 and 13, right? Yeah, I can see, if you can see the screen, you can see it's 12 and 13 from the proportion part. So if you have any question from this, we can go for that first, okay? All right, so if you have any question, you can unmute yourself and we can chat about that. Anyone? No questions at all?
Yeah, I guess I had a quick question.
Could you please say just a little bit louder?
Yeah, sorry. I guess I had a quick question. Maybe you'll go over this later, but I was wondering if there's just any updates on the homework site or anything like that.
Yeah, I actually emailed my Open Math support system this morning that it's getting too late because the semester is already in the third week, although technically it's in the second week. Anyway, so I requested them to expedite the process so that I can use that. So let's see whether they reply me or not. But yeah, I'm getting really frustrated as well because it's taking too much time. But that's good for you guys as well, I guess, because you'll have less assignments to deal with. Meanwhile, we'll learn a good deal of problem solving as well. Yeah, the moment I get to know about it, I'll definitely let you guys know. Yeah. All right. So looks like there is no question from sample 12 and 13. And I guess I actually showed a problem quite similar to example 12. So let's go for example 13 first, okay? And then if you have any question from 12, we'll come back to it, okay? All right, so example 13 says solve the proportion. Let me write it for you. And of course, if you have the book, please have it open in front of you so that you can see which problem I'm doing. Let's start with example 13. Sample 13. And it says, solve the proportion 5 over 3 equals to x over 6. All right, so again, we'll follow the same procedure. Just don't look at the solution first. Try to see what the question is looking for. Okay, so we have an equation in our hands, clearly because of this clearly signifies that it's an equation. So no worries about that. And from this equation, they have said we need to find the unknown value of x. So we are actually looking for this guy. That means from this equation, from this equality, we're trying to find the value of x, which will keep the value, keep the equation, keep the values of this equation intact, okay? That means we're trying to find the value of x for which the left-hand side and the right-hand side of the equation will be equal. Now again, let's start it from the very beginning. Is the question clear to you guys? That's the first thing we need to deal with. Is there anything? Yeah, go for it.
Oh, I was just saying that I think the question's clear.
Okay, thank you. So the first thing, again, I'm repeating myself, but it's really important. You need to see and understand what the question is looking for, what the question is looking for. Don't go for heroics first. Don't go for the solution first, okay? So we're looking for the value of x for which both sides will give us the same value, okay? The equality will hold. Okay, now what are the properties we can use, or what are the basic algebra we can do here? So one thing we can do, if you remember or if you haven't seen this before, no worries. We'll try to go as deep as possible. So whenever you are trying to find x or any other unknown value, we want to isolate that somehow or other. Obviously, we need to make sure the mathematical rules and regulations are maintained or are not violated really, but somehow or other, we want to isolate that unknown value and keep everything else on the other side. Okay, let me show what I'm actually trying to do. That means, okay, I already have it in red. So I want to isolate this guy from the other three values. So that means in this equality, I want to have x on one side and the other three values, other three numbers rather, which is 5, 3, and 6. I want those on the other side. Okay, I'm trying to completely isolate the x. So that's what I'm trying to do. Now, what can I do? So one thing we always do to isolate whenever we have a proportion in our hands, it's the easiest way probably, is to cross multiply. Okay, cross multiply or changing sides for the numbers, for the given values. So if we want to change sides, so let me erase this. Okay, let me have it here. I'm doing it here. Okay, so I'm trying to isolate x, right? So somehow or other, I want to get rid of this 6. I don't want it on the same side with x, right? Because clearly I want that isolated x somehow or other. So this means I need to get rid of this 6. So what I can do, I can change sides for this. Okay, now let's go to the basic of changing sides. So if you have anything like this, okay, or even this, I'll show both. So changing sides means the value will have the reciprocal on the other side. Now, what does the reciprocal mean? Reciprocal means just the inverse value, you could say, in maths, or in easier words, if you have 3 on one side, you will have 1/3 on the other. If you have a +3 on the other on one side, you will have a -3 if you change sides for it. So that means it depends on how you are changing sides. So you can change sides by adding the reciprocal of it, which could be the additive reciprocal or the multiplicative reciprocal. Now, for proportions like this, clearly we will use the multiplicative reciprocal, okay? And let me have another one here. If we have equations like this, additions and subtractions, then we'll use the additive reciprocal. I'll show examples of both. So let me have examples here. I'm not going to spend too much time on this, but trying to just make sure. So if you have, let's say, 3 plus x equals, let's say, y plus 7. So if I am trying to isolate x, that means I'm trying to get rid of this. And this 3 is actually adding an extra amount with x. That means if we can subtract it from both sides, then we can get rid of this. So as I said, if we have a +3, then we can use -3 to nullify that, okay, to get rid of that. So if I do that, I'm just using let's not use the parentheses here, y + 7. Okay, so now what did I do here? Whenever you have an equation, if you operate anything, if you add anything, if you subtract anything, you need to do that on both sides. Otherwise, the value will get changed. And we don't want to do that because we have an equality. We want to keep that intact. So if I subtract 3 from the left side, we have to do the same on the right side as well. Whatever we do, we need to do that on both sides. So now we had 3 plus x. I have a -3 here. We had y + 7. I have a -3 here. So this is actually keeping the equality intact, okay? So there is no harm in doing that. Now, this -3 and +3 will nullify each other. You can clearly see this will cancel each other, right? And finally, we'll have this x on the left, and on the right, we'll have y, and this -3 + 7 will give us a +4. So now we have an isolated x. That means whenever we have equation like this with plus or minus, we can actually use the additive reciprocal. That means, or inverse, I should say. That means to add or subtract the same value from both sides. That's another thing. We need to do the same thing on both sides. So we have a +3 here. If we want to get rid of it, we'll subtract 3 from each side. So obviously, we need this on the left side, but to keep the value intact for the equation, we need to do that on the right side as well. So that way, we can get rid of that, whatever value we have, and we can isolate this x. Now, what if we have a proportion, or let's say a product? Let's say we have like this. Using 3 too much will look awkward. So let's see some different values. Let's say we have 35. Okay. Now we want to isolate this x again. That means somehow or other we're trying to get rid of this 5, and this is actually working as a product with this x. So if we want to get rid of this, we need to divide this by 5, because that way those 5 will cancel each other. Okay, let me show this here. So if I can somehow divide this by 5, you can clearly see this will help us to get rid of this 5, right? Now, again, if we do that on the left side, we need to do that on the right side as well. And this will give us x equals 7, because this 5 goes 7 times into 35, right? So our final result will be x equals 7. That's not the problem. We are trying to isolate x. Meanwhile, we have our result as well. Not always we'll have that, but somehow or other, we want to isolate this unknown value. That's the main thing. So the main property is we want to use the reciprocal. If we have anything as a sum, we want to subtract it. If we have anything as a product, we want to divide it, and vice versa. Okay. Now a quick question: how can we isolate the x on our given problem? Whoever answers this first will get a +1 in the first homework. Go for it. How can we isolate the x on this problem? What should we do?
Can you multiply both sides by 6?
And why do you think we can do that?
Just because it would isolate the x. Like
Okay.
you can multiply both the denominators.
Right. So we're trying to get rid of the 6, right? And this is actually the denominator of a fraction. So if we somehow multiply this side by 6, let me use another line here because there are too many colors and I might get tangled in between. So let's avoid it. So I have a 6. And if I somehow multiply it by a 6, I can clearly see that this will help me to isolate my x, right? And obviously I need to do that on the left side as well. So what I'm doing here, I'm actually multiplying both sides by the denominator because this will help me to get rid of the 6 I have with that x. And this will also make sure I can isolate that x. And this 3 goes twice into 6. So I'll have 10 because 5 times 2 gives me 10. So the value of x will be 10 on this occasion. Now, before we go any further, any question from this? Don't look at the solution, the way they have done or the description they have. Don't look at that. Try to see why we have done this. What's the reason we have multiplied both sides by 6? If you understand it, the rest will be pretty simple.
Couldn't you just have cross multiplied and divided because you get the same answer?
Yep, of course.
Okay, cool.
Any question from this? These are really basic properties, and you will actually use this to solve harder problems in future. I'm not sure whether in this course or not, but definitely in future. So if you have any doubts, you should go for it now. No questions at all? Cool. Let's move forward then. Okay, so example 14. If you have that in front of you, first try to see what the question is looking for. So the question says a map scale indicates that ½ inch on the map corresponds with 3 real miles. Okay, how many miles apart are two cities that are 2 okay, so that's 1/4, right? Yeah, inches apart on the map. Okay, again, hide the solution. Don't look at it in the first place. What you want to do is to see what are the informations we have and how can we use those to get to our result. So first of all, if you have seen a map before, you will see, let's say that's the map of Wyoming. That doesn't look like a perfect square. Let's say that's the map of Wyoming. Okay, and if you have seen this before, I'm not sure whether you noticed or not, there is a scale, a particular scale for each and every map, because simply because you can't really adjust the real distance, the real, yeah, I would say the distance would be the perfect choice of word, the real distance or the real length, I would say, in a piece of paper, right? Because for example, it's about 40 miles if you drive it from Laramie to Cheyenne. So if you want to draw a map from Laramie to Cheyenne, then you can't really have 40 miles in a single piece of paper, right? So that means you need to rescale that somehow so that you can show that how does it go from Laramie to Cheyenne, you know, passing different places, different points, and also you can show the road it's going to take. I mean the direction it's going to go. So that means as you can't really fit that 40 miles within this smallish place, if you still want to show that, you need to somehow rescale it. So for example, if I say 1 inch on this paper signifies 10 miles. Now what does that mean? So from Laramie to Cheyenne, let's say that's 40 miles. Okay, for example, I'm saying that 1 inch on this page means 10 miles, 10 real miles, okay? So if I have 4 of this, I'm going to join this, though I'm just showing this individually so that you can see what's going on. So that's 4 of this, right? So this green line will signify 40 miles. Can you see what's going on here? Although it's not really that class where I need to show you the rescaling part, but if you are wondering what's going on here, that's the part. So 1 of these means 10 miles. So for 40 miles, I need 4 of this. So if I add this, that will be my Cheyenne and this will be my Laramie. So that's how map rescales everything, okay? And for this particular problem, half an inch on the map means 3 real miles. So let's say this is half an inch, okay? And on the actual direction from whatever the place is, it's not really mentioned, it will actually mean 3 miles. That the distance from one place to another, from here to here, will mean 3 miles, okay? All right, so now they're saying we have a city on that map, which is 2.2 inches apart. So let's say these are the cities. The first city is A, the second city is B. And on the map, this red line is 2.25 inches. So what the question is looking for is what's the actual distance between these 2 cities? Now is the question clear again? Anyone, if you want me to rephrase it, if you want me to re-explain it, I'm more than happy to do that. Just make sure you're getting the question first, okay? Let's say that's a map, although it's not really given here. This figure would have made things more clear, but that's how it is. So let's say that's the map, and that's 2 cities, 2.25 inches apart from each other on this particular map. Let's say that's a map, okay? And 1, or rather half an inch, means 3 miles. So the question is, what's the actual distance between these 2 cities? So now we will use the property of proportions, okay? So half an inch means 3 miles. Thinking outside the course shell. Anyway, forget it. Okay, half an inch on the map. So that's on the map, and that's the real distance. We're taking the proportion. So on the right, will have the same proportion again. Because whenever you have an equality, as I said before, you need to have the same things. You need to have the same units, same unit rather, okay? So on the left, we are taking the proportion of the distance on map, the length on map rather, and the real length. So on the right, we'll do the same, the proportion of map over real. So half an inch means 3. We have taken that proportion, and we have 2.25 inches, or you can use 2 1/4. And what should be my denominator as I'm taking the proportion? Because if you can set up the equation, the rest would be the same as the, what was the example again? Example 13. If you can set up the equation, the rest will be just the same as example 13. So it's really important that you set up the equation right. Otherwise, you'll get different results, okay? So clearly, I'm taking the proportion of map and the length on the map and the real length. So for 2 1/4 on the map, I'm actually looking for the real length. So let's say that unknown is X, okay? Because we don't really know that. What's the real length on real length for that 2 1/4 inches on the map? So as I'm taking the proportion of the lengths for map and the real one, so for 2 1/4 inches, the real length is unknown. So let's say that's X. So if I write that clearly, this is the equation. After all that hard work we have done. Before solving it, before going any further, any question from this? How did we reach this? Take your time, okay? Breathe in, breathe out, and see if you have any question from this.
For future problems, if we want, can we change the fractions to decimals if it's easier for us to figure out?
Of course, yeah. Definitely. To be honest, I like to use decimals as well. Yeah, you can definitely do that. No problems with that. And I think I have already used it. Yeah, somewhere. Yeah, there it is. I've already used it. Anyway, the way you like, as long as you are not really missing it somewhere in between, you know, converting these decimals to fractions and all that, you should be doing fine. All right, no questions from this, from the equation we have got. Although we have actually set up ourselves, but it's really important. So looks like there is no question. Let me see the chat. No, it looks fine. Okay, so let's solve this now. Okay. Once again, we want to find the unknown value, and on this occasion, it's this denominator x, which we are looking for. Okay. Now, what should we do to isolate this x? If it was in the numerator, we would have multiplied both sides by the denominator. But on this occasion, our unknown value is actually on the denominator. Now, how should we rather isolate this? What should we do? What's the operation we can do here? So for that, cross multiplication is, as I mentioned before, is one of the easiest things to do. And how can we do that? Let's see that. If we have a fraction like this, cross multiplication means just go for this direction. Okay, that's your cross multiplication like this. Okay, that looks like a cross. So you can say cross multiplication. So that means it will be A times D equals to B times C. And this will still be equal, and this will do no harms to the value of the equation. This will keep your value of the equation intact. So we can clearly do that. So cross multiplication often makes our life easier. Okay, and then we can again use that same procedure to isolate, like this. We can use the reciprocals to get rid of the additional terms we have. Okay, so first let's cross multiply it. So it will be x times half, right? I'm showing it for you. So it will be half times x, and it will be 3 times 2 1/4. So it will be 3 times, I'm going to use 2.25. And now this looks much easier, but still the x is not really isolated. So what should we do? We're trying to get rid of this half. So what should we do? If you remember, we can actually, let me rewrite it for you guys so that it looks even more convenient. This is basically x over 2, okay? This half times x is basically x over 2, right? So if we have anything like this, we have seen this before, we can, what is that again? Oh, here you go. We can actually divide both sides by that, whatever value we have associated with that x. So on this occasion, we have 2, and this is actually the denominator of the fraction. So we can actually multiply both sides by that. So what you can do, you can multiply both sides by that. If you want, you can already have this value here, which is, I believe, 6.75, right? So let me use 6.75. Okay. So what I'm doing here, to get rid of that 2, I'm multiplying both sides by 2. Obviously, we need to, whatever we do, we need to do that on both sides. So in particular, to get rid of this, I'm multiplying by 2, clearly because it will cancel each other and, oops, sorry, and help me to isolate x, okay? And obviously we need to operate the same thing on right side as well. So we have done that, and finally we'll have that isolated x, and 2 times 6.75 would give us, I guess it's 12 and half, so it should be 13.5. Right, 6 times 2 is 12, and 0.75 times 2 is 1.5. Yeah, it should be 13.5. So that means our final result means the actual distance between these two cities is 13.5 miles. That's our result. Any question from this? I'm going back to the solution part again. Take a close look at this and see if you have any question. Oops, I think I should go one step. Yeah, this one. Take your time and clarify anything if you have any doubts, because we are actually doing several things on each step. We are doing different operations. We're cross multiplying, we're setting up the equation, we're isolating the x, you know, we're doing different things. No questions at all? All right, so now let's look at this solution. I mean, the way they have done, okay? It's going to be the same way, obviously, but the reason I'm saying to look at the solution at the book, because whenever you are given a question like this, if it's a multiple choice question, then there is no question of showing your work. But if it's a free response question, then obviously you need to write these stuffs in English, okay? Not only these mathematical terms, you also need to use different phrases to express this in English words, right? Like the way they have done in example 4, and if you can see that. And on top of that, you need to have these side notes. As you can see, on each step, they have shown what they have done in that particular step. For example, in the first one, they have said multiply both sides by x and rewriting the mixed number. Then you can see they have said multiply both sides by 3. And the last one, they have said multiply both sides by 2 or divided by half. That's equivalent, so you can write it anyway. But whenever you are given a free response question, you need to have these side notes on each step. Whatever you are doing, you need to write that next to that particular step, okay? Otherwise, you might get penalized. For example, if it's a 10 points question, then you might get 2 or 3 less if you don't have these side notes. Because I know you know these stuffs, but obviously as a mathematician, we need to have this so that whenever a non-mathematician observes this, he can actually see what's going on. Okay, that's why we actually write these stuffs as side notes. So what I want you guys to do, I generally don't penalize anyone, but if it's a 10 points question, you know, there are too many several parts where I need to grade, you know, for setting up the equation 2 points, for cross multiplying 2 points, you know, for getting to the final result 3 points, you know. I'll have different rubrics. I'll show that once we start those things. But for getting full credits, you need to have these side notes, and obviously you need to express everything using right words. Although these are really simple words, but you need to set up the equation, you need to solve it, and you need to show what you are doing here. Okay. Any question up to this? No questions at all? Okay, now let's go to page 8. What can you see at page 8?
Unit conversions or the example?
Questions? Yep. So that's really important. Across the world, we use different units to measure different things. For example, the way the British do, the Americans do it in a different way. You know, those miles and kilometers and all that. So different regions have their own, you know, different measurements. So you need to know the conversions, because the question might give you a unit which you don't really know. If you don't know, you can't really solve it. That's the problem. So you need to know the conversions. So what I want you guys to do is to sort of memorize this, because as I said, I'm not sure whether sorry for that. Can you see my screen?
Yeah, you're still there.
Okay, sorry. So what I want you guys to do is to memorize this, simply because I'm not sure whether I'll be allowed to give these formulas or these conversions in the question, but I'd like to do that. Generally, if I'm allowed, I tend to provide you the formulas or whatever you need, the additional informations. Okay, but until then, I want you guys to have this box with you. Either memorize it or have it with you in a separate place, so that whenever you need this, just open it quickly and see the conversions. Okay, so let's use this, and let's see whether we have a problem which needs this. Okay, yeah, example 16, the very next one. Clearly you can see the question is given in miles. I mean, the information is given in miles, but the final output is in feet. So clearly you need to know the conversion. I mean, what 1 mile, how many feet it will be for 1 mile, or the vice versa. You need to know these conversions. Otherwise, clearly you can see, although you can set up the equation, you can cross multiply and do different things, blah, 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 but you can't really get to the final result. So let's first see how much, or rather, what's the conversion rate? Okay, conversion, not conversion rate, rather, sorry, that's conversion. Yeah, the second one, 1 mile equals to 5280 feet. If you see the box of unit conversions, the first topic is length, and the second conversion in that is this: 1 mile equals to 5280 feet. All right, so we'll have this information now and try to use this to find our result. Okay, so the question says a bicycle is traveling at 15 miles per hour. So 15 miles per hour. Okay, and the question says we need to find how many feet will it cover in 20 seconds. Okay, so you can see we need to convert this miles to feet and this hour to seconds, right? Yeah, seconds. We need to convert both of these units. If you somehow miss any of these, you'll get a different result. And unfortunately, that will not be right. So you need to see each and every part, as I'm repeating myself every day. Try and see each and every word. So this miles need to be converted to feet, and these hours need to be converted to seconds. Now let's do that first, and then we'll go for the equation setup and all that. Okay, so we have 15 miles. Okay, so what you can do when we are setting up the equation, we can do two things. Either of these two. Okay, we can keep every units miles per hour. I mean, both sides we can keep it miles per hour, or we can convert it to feet per second. Sorry. But again, whichever unit we have, we need to have the same unit on both sides, either 1 or 2, not both. Okay, if you are using 1, you need to have the same unit on both sides, and same goes for the second one as well. So if I have enough time, which I don't really think I have, so let's go for only 1. If I had enough time, I would have shown both those, and you would have seen the result is actually the same. Okay, so let's convert. Okay, the book has miles per hour, right? Oh no, they have, okay, they have done it in a sophisticated way. I guess I'll avoid it. Okay, so I have 15 miles. So I can use feet for this. So 15 miles will be 15 times, what was the unit again? 5280. 5280 feet. Clearly you can see the unit is getting changed, right? As I'm multiplying by that conversion. So can anyone do that for me? Okay, let me do it. 15 times 5280 gives us 79200. Or you can keep it like this. Okay, that will be the feet, and an hour. So, oops, sorry. If we convert an hour to seconds, how much that would be? Anyone? That's the easiest, right? 1 hour equals to seconds, right? If you don't know that, you can note it down, or if you have it in the box, I'm not sure. No, you don't have that in box, but that's pretty obvious one. Anyway, so we have converted everything from miles per hour to feet per second. Now we need to set up the equation. Let's do that without wasting any more time. So we have 15 miles per hour. So it would be 15 times. I'm not really using the final product. I'm keeping it so that it's easier to cancel out one or two things. And per hour will give us 3600 seconds. You know, from miles per hour, we have converted to, you can clearly see, feet per second. And for the next one, that's the proportion is feet per second. Okay, so on my right, I need to have feet per second as well. What's the given second here? 20. And we are looking for the distance in feet. That's the unknown part, so that would be our x. Okay, and then if we solve it, I wish I had more time to explain it. Hopefully I'll do that next time. So if I cross multiply this, I can isolate this x. It would be 20 times this 5280. Pardon my bad handwriting. Or I can actually write this as 60 times 60. This will help me to cancel out easily. Okay, now if you solve it, you will get 440, and that would be your final result. We are running short of time, so I'll end it here today, but hopefully if you see this again, I'll send you the recording soon after I finish. Hopefully if you see this over and over again, you'll be able to understand what did I do here and how did I do it. Okay then, so for Wednesday, I want you guys to solve Try It Now 4. Okay, let me write it for you. The homework will be Try It Now 4 and go over the examples 17, 15. I didn't show 15, right? Yeah, so go over the examples 15 and 17 and see if you have any question. So this will be your pre-class assignment. Okay.
Do you want us to email you our work and solutions for those?
Only for Try It Now. Yeah, this one, not for the examples. You already have the solution there. You just need to see whether you can understand it or not, or if you can generate any question from those. Yeah, for Try It Now 4, email me or send me in Canvas, whichever works for you. Okay. All right. I'll see you guys on Wednesday.
Thank you.
Thank you.